In this video, we're going to talk about distance and displacement. Let's say your house is right here and you start out at your front door and you leave your house and you go 3 miles east and then you turn and go 1 mile south and then you come back 3 miles to the west and you end up here. So how far did you go? So there's two ways to answer this. And the first one is with your distance. So distance is going to be how far you walked in total. So anytime you're looking for distance, just add everything up. So I drove my car 3 miles plus 1 mile plus another 3 miles, and I used 7 miles worth of gas in my car. So my distance was 7 miles. But there's another way to look at this, and that is how far did I go? Well, if I look at my displacement, then, I started at my door, and even though I drove all the way over here and back, I'm actually not too far from my house. Well, how far am I from where I started? I'm actually only a mile from where I started. So displacement doesn't actually look at the entire trip. Displacement is going to be the change in position. And if my position started here, I'm actually only a mile from where I started. So my displacement is 1 mile. And I can actually say that I'm 1 mile south of where I started. So my position started here, it ended here, and so I've actually only moved 1 mile south of my starting place. And that is another difference between distance and displacement. Distance is what we call scalar, and displacement is a vector. Scalar quantities don't have direction. So some quantities have direction and some don't. If I were to ask you for your mass, or the mass of an object, that would not have a direction on it, so that would be a scalar quantity. If I asked you for the time, it wouldn't have a direction. That's a scalar quantity. If I asked you for the volume, that wouldn't have a direction. That's a scalar quantity. Distance is a scalar quantity. Displacement is a vector. Vector quantities have direction. So this displacement, I can say not just that I'm 1 mile from the house, but that I'm 1 mile south of the house. The real thing with vector and scalar, when we say direction, it's not necessarily south and north, east and west, but positive and negative. So if you have distance, you can't go a negative distance. Your distance could be 0 if you don't move, but if you move, this number is always going to get bigger. It can never go negative, but displacement can go negative, because if you start out here, but you end up over here, then you've actually gone in a negative direction from the origin. So scalar quantities have no direction, and vector quantities have direction. So displacement is the change in position. Now, we're going to call position, since we're moving back and forth in the x-plane as opposed to up and down in the y-plane, we're going to call this our x. Displacement is the change in position. So delta means change in, and x is the position. So let's say we start out not at the origin, but let's say we start out here at +1. And we're going to move 2 to the right. Then we're going to turn around and we're going to move back. We're just going to go backwards, and we're going to go until we reach the -1. And we're going to stop for a while, and then we're going to keep going until we reach -4. And then we're going to move back along the same line until we reach -2. So we started out here at 1. We moved to 3. Then we went back to -1. Then we kept going to -4 after we stopped for a while. And then we turned around and went and got back to -2. Now, if we want to know our displacement, there's two ways you can look at this. You can say, okay, I went in this blue section here, I went +2. I started at 1 and I moved 1, 2 to the right. And then in the green section, I'm moving to the left. So I went 1, 2, 3, 4 to the left. We're going to say that's -4. In the red section, I went 1, 2, 3 to the left. So that's another -3. In the purple section, I went 1, 2 to the right. So +2. So overall, if I look at my two positives, I went +4. And my two negatives, I went -7. And +4 minus 7 is -3. So my displacement is -3. Now, there's an easier way to do that. Displacement is the change in position. And your change in position is going to be whatever your final position was. We're going to call that XF for final position, minus whatever the initial position was. We're going to call that XI for initial position. My initial position was here at 1. My final position was -2. And so my change in position is going to be my final position, -2, minus my initial position, 1. -2 minus 1 is -3. It really doesn't matter what all happened in between. All that matters is I started here and I ended here. And so I went 1, 2, 3 to the left, -3. Now for my distance, remember, I don't care which direction I went. I did a lot of walking. And so I'm going to go ahead and make sure I add all of that up. So I went 2 and then 4. It doesn't matter that I went back left because there's no direction here. This is a scalar. And then I went another 3 and then another 2. And so for my distance, I'm just going to add all that up, 11. Now let's say that Joe walked 15 meters east and then turned north and went 20 meters. Now, if I wanted to know his distance, simple, 15 plus 20, 35. But his displacement is a little more difficult because in this, he has displacement along the x-axis or east-west, but then he also went north, so he has displacement on the y-axis or north-south. So I can't put this on a number line like the last one. For this, he started here, he ended here, so this is his initial position, and this is his final position. And so this would be his displacement. Now, what do you notice about this? Well, what you notice is that this is a right triangle, and that his displacement is the hypotenuse of that right triangle. And if you remember, how do you find the hypotenuse of a right triangle? Well, you use Pythagorean theorem, which is a squared plus b squared equals c squared. Remember that c is what you're looking for. That's the hypotenuse of your triangle. A and b doesn't matter, so 15 can be a or it can be b. It doesn't matter which leg is which, but c is the hypotenuse. So your displacement squared is going to be equal to a squared plus b squared, or 15 squared plus 20 squared. You're going to end up needing to take the square root of both sides. And so 15 squared plus 20 squared square root is equal to 25 meters when you put that in your calculator. So this distance here was 25 meters. This is displacement, which is a vector. Technically, you should have a direction, but the direction isn't just northeast. You would actually need to come in here and calculate this angle to determine the direction that you're heading. We could do that with trig, but we're not going to do that just yet. We'll talk about that later on in the semester. Let's do one more like that that's similar but not quite. So let's say that I start there, I go 200 meters south, and I go 400 meters west, and then I go 600 meters north. So what's my displacement? Well, I started here and I ended here, so I'm looking for this distance. Now there's a couple ways you can look at this. Again, I went 200 south, so that's -200. I went 600 north, so we'll think of that as being positive. And so that ends up being positive 400 north. And then I still have my 400 to the west, which is negative 400. I can also just recognize that since I went down and then back up, this ends up being 400. Okay, again, same thing, I did it in my head, I didn't do it mathematically. And then this side is 400. So essentially I'm looking for this right triangle here that has sides of 400 and 400. We're looking for the hypotenuse again. So my displacement is going to equal the square root of 400 squared plus 400 squared. I'm not really worried right now about the negative or the positive here because I'm going to square it, so it's not going to matter. You may end up in your calculator, if you try and keep that positive and negative, you may end up with problems because if you do it wrong, then it'll be a negative underneath the radical. So don't worry about doing that. So the square root of 400 squared plus 400 squared ends up being 566 meters. So I went 566 meters, somewhat in a northwesterly direction, but again, I would need to figure out this particular angle, which we'll talk about later. But if you can get the 566 meters part, then that's all you need for right now. I want to touch on one more concept, and that is the term magnitude. So if you have a vector has both a magnitude and a direction. The term magnitude just refers to the number. So for example, this vector is 35 meters south. Well, the magnitude of this would be the 35 meters part. South is the direction. So a vector has both a magnitude and a direction. If you have a scalar, it just has the magnitude. Let's say that my velocity is negative 25 meters per second. Well, the magnitude of that is the fact that I'm going 25 meters per second. The negative means I must be probably going west or to the left, negative 25 meters per second. That negative gives me the direction. The 25 meters per second is the magnitude. So on Earth, acceleration due to gravity is negative 9.8 meters per second squared. The magnitude of the acceleration is 9.8 meters per second squared. And normally, if I asked you what gravity was, I'm really talking about the magnitude. I mean, I'd say, what's gravity? And you would say 9.8. Now, technically, gravity is pulling you down towards the center of the Earth. So down would be in the negative direction. So it's negative 9.8. That's a vector because it has both a magnitude and a direction. The magnitude would be the 9.8 meters per second squared. So car A is going negative 3 meters per second. Car B is going 2 meters per second. Which car's velocity has the greatest magnitude? Well, the answer would be that car A has the greatest magnitude of velocity because it's going 3 meters per second. It's going faster than car B is. Now, it's going left and car B is going right. And if you look at those two numbers mathematically, 2 is greater than negative 3. But we're not really looking at that mathematically. We're looking at the fact that this one is going 3 and this one's going 2, so this one is faster. So just be careful with that concept of magnitude. That's what it means. Hopefully this explained to you the difference between distance and displacement and some of the idiosyncrasies with displacement. Let me know if you have any questions.